Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular paper is November 2019, paper 3, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to be looking at November 2019, paper 3, which is the calculator paper. So let's get into it. Question 1. Circle the relative frequency that represents 13 successes out of 50 trials. Well, do you remember the formula for relative frequency? Relative frequency, that is equal to successful trials over total trials. Okay, so you conduct an experiment so many times, you count up your number of successes and you divide one by the other. So in this case we've got 13 successes out of a total of 50 trials, which is 13 50ths, which is 26 100ths. That's 0.26 then, isn't it? It's going to be that one there. Question 2. The equation of a straight line is 2y equals 3x plus 5. Circle the gradient of the line. Okay, well you can read the gradient out of an equation of a straight line as long as it's in the form y equals mx plus c, where m is the gradient and c is the intercept. Okay, so we need to rearrange this equation to make it look like this, and then we can just simply read out that coefficient of x, and that's going to be our gradient. Now at the moment it's not quite the same because this term at the front is 2y and not y. Okay, so to get it to look like y equals mx plus c, we're going to divide both sides by 2 to start with. Okay, so 2y divided by 2, that's just y. 3x plus 5 divided by 2, you can actually break that into 2 separate divisions. Okay, so you can think of it as 3x over 2 plus 5 over 2 dividing everything by 2, which is going to be 3 over 2x plus 5 over 2. Okay, so this here then is the gradient. The coefficient in front of x is 3 halves. This thing on the end is the y-intercept, but we don't need to know that right now. It's just the green one, isn't it? So that one there, 3 over 2. Question 3. 2x minus 4 times 3x plus 5 is expanded and simplified. Circle the term which is part of the answer. Okay, well when we do double brackets like this, I don't know how you remember it, I just remember it as 2 eyebrows, a nose and a mouth. So multiply, or some people remember it as FOIL, first, outside, inside, last. Some people even do it as a grid, so 2x minus 4 and 3x plus 5, which whatever way you do it, you end up multiplying 3x and 2x together, which is going to give me 6x squared. 3x and minus 4 together, it's going to give me minus 12x. 2x and 5 together, it's going to give me 10x. And then 5 and minus 4 together, which is going to give me minus 20. So that gives me 4 terms altogether So you'll notice that two terms are alike though, aren't they? These two here. So collecting like terms together, I end up with three terms. It's going to be 6x squared. 10x take away 12x is minus 2x, and then I've got minus 20 on the end. They're my three terms. So are any of those in that list there? Yes, this one here is, so it's minus 2x. Question 4. When rounded to three significant figures, x equals 6.37. Circle the correct error interval. Okay, now if this number has been rounded to three significant figures, you can imagine it on a scale. There it is, 6.37. One division up would be the third significant figure, that hundredth. So that would be 6.38. And one down on the scale would be one less, that would be 6.36. Now the numbers that round to 6.37 then are going to be the ones that are halfway between or closer. Okay, so this range, these are the numbers that are going to round to 6.37, aren't they? Okay, so what's halfway between 6.36 and 6.37? That is going to be 6.365. And halfway between 6.37 and 6.38 is going to be 6.375. Okay, so it's going to be the ones with 635 and 6.365 and 6.375. So there's only one there that fits. It is going to be this one. I thought there might be some more. You'd have to double check the symbols as well. But notice it's a greater than or equal to on the left and a less than on the right, strictly less than. Question 5, solve the simultaneous equations. Now this is a very easy, straightforward simultaneous equation because look, I've got a 2y there and 2y there, so I can just eliminate the y straight away by subtracting these two equations from each other. So subtracting like with like, 7x take away 3x, that's 4x. 2y take away 2y, they're going to cancel each other out, aren't they? They're eliminated. And then finally I've got 36 minus 16, that is 20. So that gives me 4x equals 20. Now I just need to divide both sides by 4. So that's going to give me x is equal to 5. Okay. Are we done? No, we've only got half the solution here. We found x, but we now need to find y. We can do that by just picking one of our equations and subbing x equals 5 into it. Let's just take the first one. So let's substitute x equals 5 into, well, this is equation 1, this is equation 2, so we can say into equation 1. So 7 lots of x, 7 lots of 5 plus 2y is equal to 36. Well, 7 5s are 35. And then if I take 35 away from both sides to get rid of that 35 on the left, that is going to leave me with 2y is equal to 1. So dividing both sides by 2, I'm going to get y is equal to half, aren't I? Okay, so then the solution is x equals 5, y equals a half. Okay, now at this point, you can just check it by shoving it into the other equation. Okay, always a good idea to do this. It's better to check it in the exam rather than when your results come back. We worked out using equation 1, so let's just check it in equation 2. So just going to sub in both numbers and make sure it's true. So 3x, 3 lots of 5 plus 2 lots of y, 2 lots of a half, is that equal to 16? Well, 3 5s are 15, 2 halves are 1, and 15 plus 1 is 16, so that is okay. So that's just a quick way of checking that you've got the right answers. Let's move on. Question 6a. Tom is tiling a wall. He needs to buy at least 100 tiles. The tiles are sold in large packs and small packs. Large packs come in 40 tiles and they're £18. Small packs come in 28 tiles and they are £14. And there's a special offer on at the moment, 25% reduction when you buy 3 or more large packs. Okay, so work out the cheapest cost for Tom to buy the packs of tiles he needs. Okay, well, there are different combinations he could use, isn't it? So the large pack has got 40 in it and the small pack has got 28. So one possible way would be 3 lots of the large ones. That would be 40, 40, 40, wouldn't it be 120? And that would qualify for the discount, so that's possibly a cheap way of doing it. 28 tiles. We could do 4 packs then, couldn't we? Do 4 of the small ones. That would also give me enough tiles. 100, just over 100, wouldn't it be? 112. Or there should be some combinations we can do as well. We could buy 2 large and a small, so 40, 40 is 80, and then the 28, that's going to give me 108 tiles. That should be enough as well. Are there any other combinations? So 3 large ones, 2 large ones and a small one. Is there 1 large one? 1 large one would be 40 tiles, and then could we make, we'd need we wouldn't have quite enough for 2, would we? We'd have to have 3 small ones. I think that's going to be a little bit cost prohibitive, that one. Or we can have 4 small ones, no large and 4 smalls. Okay, so they're the 4 different combinations. I'm doubting large plus 3 smalls is going to be the best. Now let's work out those different combinations. Okay, so let's try working out 3 large ones to start with. Now 3 large packs, it's going to be 3 lots of 18. Now remember though, we get to apply the £25 reduction, 25% reduction. Now if you've got 100% and you reduce it by 25%, that leaves you with 75%, and 75% as a multiplier is 0.75. Okay, so to work out the cost here, I'm going to multiply it through by 0.75 at the end. Okay, so 3 times 18 times 0.75, that one comes to £40.50. Okay, it's in pounds and pence. I should really put 2 decimal places after the point. What was the next combination? 2 large and a small. That's going to be 2 times 18 plus the 14 then, isn't it? So 2 18s plus the 14, that comes out to £50. Okay, so I think that the 3 large ones are going to be the cheapest then, so that's 50. Let's just double check the other combinations. We could have a large and 3 smalls. Large and 3 smalls. That's right up here because I ran out of space. It's 1 lot of 18 plus 3 lots of 14. So 3 14s, 14, 28, 38, 42, and 18. That's £60. Finally, we can have 4 small ones. 4s, which is just 4 lots of 14. So times it by 4, double and a double again. 14, 28, 56. It's going to be £56. Okay, so we've got all the different combinations now. Just need to pick out the cheapest one. It's that one there with the discount, isn't it? £40.50. So that one there, cheapest. 6B, Tom is also tiling a floor. Oh, he must be bored in lockdown or something like that, and taking up his time with lots of DIY. Good job, Tom. Now, the floor is a rectangle with length 600 centimeters and width 240 centimeters. Each tile is a square with side 40 centimeters. Tom uses this method to work out the number of tiles he needs. So the number of tiles that will fit along the length is 600 divided by 40, which is 15. Is that right? 600 is the length, and each tile was 40. Yes, so if I do 600 divided by 40, I'm just going to check his maths as we go along. So yeah, that is 15. Okay, I'm happy with that, and I'm happy with the answer. The number of tiles that will fit along the width is 240 divided by 40. So 240 divided by the same 40. So that is correct. Let's just double check the maths. 240 divided by 40. 6. Yep, that's good as well. So the total number of tiles needed, 15 plus 6. Huh? Tom, what are you doing? That's not right. That is not correct. Because it's basically a grid, isn't it? So you're going to have 15 rows this way and 6 rows this way. So you're going to have to multiply them together, aren't you? It's going to be 15 times 6. Okay? So that's what we need to write. That's his error. So Tom has added instead of multiplying. Question 7. An equilateral triangle has side length 16 meters. Using a ruler and compasses only, construct a scale drawing of the triangle. Use the scale 1 centimeter represents 2 meters. Okay, so if I'm going to be using 1 centimeter representing 2 meters, 16 divided by 2 is 8. So each side is going to be 8 centimeters in length. So first off, let's just draw the baseline with a ruler. Just drawing out 8 centimeters in length. Okay. Next, using your old short dumpy pencil that you've saved, set your compass up. Don't forget to put the point of the compass and the pencil tip in the same point when you tighten it up. And again, set the aperture of your compass to the same 8 centimeters because it's going to be an equilateral triangle. All the sides need to be the same. And then stick the pointy end of the compass at one end of your line. Don't forget to hold it from the tip. That's how you're meant to hold it. Okay, you can twirl it around, draw one of your arcs, move to the other point, the other end of your line, and draw a second arc. And you should find that the two arcs form a little cross. Okay, and then the next thing you can do is just join that point that's made there with the ends of your line, and it should form your equilateral triangle. Now, as long as your compass didn't stretch while you were drawing your arcs, you should find it is now spot on 8 centimeters, and the job's a good one. Okay, don't forget to leave the construction marks there visible, though. The examiner needs to see those to give you the full mark, so don't rub those little cross lines out. Question 8. In a choir there are 35 men and 48 women. The probability that a man chosen at random wears glasses is 2/5. The probability that a woman chosen at random wears glasses is 3/8. Work out the number of people in the choir who wear glasses. Okay, well, probability is equal to successful outcomes divided by total outcomes. Okay, that's the probability formula. Let's take this first one. The probability that a man chosen at random wears glasses is 2/5. Okay, so that means the probability of man glasses, not grasses, glasses. Successful outcomes over total outcomes. Well, we know that the total outcome is the number of men there are to pick from, so that's going to be 35. Okay, and we know that we've been given the probability here, which is 2/5. So then what must go here then? Okay, well, if you think, how do I get 35 from 5? I have to multiply that by 7. So if I do the same here, then it must be 14 men wearing glasses then, mustn't it? Okay, we can do the same thing for women as well. So the probability of woman glasses, that is going to be something over the total number of women, which is 48. And then we know that that is 3/8. Okay, so again, how many times does 8 go into 48? that goes in 6 times, so multiply that up by 6, and that's going to give me 3 lots of 6, that's 18 women wearing glasses. So then the total is going to be 14 plus 18 then, isn't it? Which is 28, 32. Okay, so the answer is 32. Part B says a person is chosen at random from the choir. Work out the probability that the person does not wear glasses. So probability of not glasses, that's 1 minus the probability that they are wearing glasses, isn't it? Okay, which is 1 minus, we know that there were 32 people now who wore glasses in the choir, and there is a total number of people of 35 plus 35 men and 48 women, isn't it? Okay, so that's 1 minus 35 plus 48. That's 83 people altogether, so 32 out of 83 wear glasses. So taking that away from 1, so 83 take away 32, that's 51, isn't it? So that's 51 over 83. 51 in 83, that's the probability that the person does not wear glasses. Question 9, the pie chart shows the information about the people at a theme park. So we can see that the vast majority of people here are going to be children, and there's some women and some men. There are 450 more women than men. Work out the number of children. Okay, so there are 450 more women, sorry. So if we have a look at the angles in the center, women are 65% and men are 35%. So the difference in their angles then is going to be 65 subtract 35, which is 30 degrees. So the women sector is 30 degrees wider than the men's one. So that must be the 450 more women that there are than men. So that means that 450 people So 450 people is represented by 30 degrees. Okay, so then we can work out how much 1 degree is then. So 1 degree then would be 450 divided by 30, which would be 45 over 3 is 15. So what's the angle for the children? This is going to be, angles at a point add up to 360, don't they? So if I take away the other two, the 65 and the 35, that will tell me what the angle is for the children. So 65 plus 35, that's 100, isn't it? 360 subtract 100, that's 260 degrees. So then the number of children then is going to be 260 degrees multiplied by 15 children per degree. So what's that? 260, I think it's 3,900. Let me just double check. 260 times 15, 3,900. Okay, question 10. We've been given the formula for density. Density equals mass over volume. We're told that the mass is divided by 2 and the volume is multiplied by 4. What happens to the density? So the mass is divided by 2, be dividing by 2, and the volume is multiplied by 4. Well, if we're multiplying the volume by 4, the volume is part of the denominator, isn't it? So if we're making this 4 times bigger, that also is the same thing as dividing by 4, isn't it? So we're also going to be dividing by 4 again. So we're actually going to be dividing everything by 8. Okay, so we're halving the mass, so the numerator is going to be half as big, which is the same thing as dividing it all by 2. And the volume is going to be 4 times bigger, which means the denominator is 4 times bigger, which means we're dividing by 4 more. So dividing by 2, dividing by 4 is the same thing as dividing by 8. So it's that one there. Question 11, work out the ratio of the cube root of 512 to the reciprocal of 0.4. Okay, Well, 0.4, what is 0.4? I'm just going to write that down as a decimal first. That's 4/10, which is the same thing as 2/5. Okay, so the reciprocal of 0.4 is flipping that fraction around. The reciprocal is going to be 5/2. Okay, so the right hand side one is going to be 5/2. Now, what's the root of 512? Sorry, cube root. So, calculator. What is the cube root of 512? It is, of course, 8. I should have known that. So we've got 8 to 5 halves. Now we need to give the answer in the form n to 1. Now we don't have n to 1 at the moment. I've got 5/2 instead of 1. So in order to turn 5/2 into 1, I'm going to have to multiply it by 2/5 then, aren't I? Okay, and if I multiply that side by 2/5, I'm going to have to multiply that side by 2/5 as well. So 5 halves times 2/5, that's going to give me 1 on the right hand side. And then 2/5 times 8 is 16/5. Does that cancel down? No, just going to leave it at 16/5. So 16/5 to 1. You could write that as a decimal, but why would you? Question 12. The graph shows how much Molly is paid for working for up to 40 hours. She receives a basic rate of pay for the first 35 hours worked and a higher rate of pay for the next 5 hours worked. Okay, so you can see that the gradient is steeper in the last 5 hours, isn't it? So this is going to be her basic pay from here to here. And this bit up here where it kind of the gradient increases, that's the higher rate of pay represented by the higher line on the graph. Okay, so what do we need to do? We need to work out the difference between the higher rate of pay and the basic rate of pay. Give your answer in pounds. Okay, well the rate of pay is going to be the gradient of the line, isn't it? So all I really need to do here is work out the gradient of this triangle here and the gradient of this triangle up here and compare them. So this is the basic rate down here then. So changing y over changing x, the height of this line here, can you see it goes up to, well, this is 250. There are 5 individual divisions between 250 and 300. So each one's going to be worth 10. So then the height here is 280 and the width is 35. So the basic rate is going to be 280 divided by 35. Okay, changing y divided by changing x. So 280 divided by 35. That's £8 an hour then. That's her basic rate. Okay. Now the higher rate is we're going to work out the same thing. We're going to work out the gradient of this little triangle up here. So this goes from 350 down to 280. So that spans 70 in that direction and 5 hours in that direction. So then the higher rate is going to be, well, what's it going to be? It's going to be £70 divided by 5 hours, which should be £14. Okay, are we done? No, because we want to work out the difference between the higher rate of pay and the basic rate. Okay, so we need to work out the difference then. So the difference is going to be equal to the higher rate subtract the basic rate. So it's going to be £6. Okay, so she earns £6 more. Question 13. Naga states the hypothesis: most people read more than 100 books a year. She asked a sample of 5 people in a book club how many books they read last month, and the table shows their results. So, number of books: Lynn read 10, Annie read 11, Paul read 8, Chen read 10, and Ruth read 13. Show how Naga could use this data to support her hypothesis. Well, she could work out an average over the year, couldn't we? Okay, so if this is a month, and we added all those books up, we'd multiply it by 12 and we divided it by 5, we'd get the average number of people, or average number of books read by those 5 people then, isn't it? So we could calculate average books read by one person over a year, and we could do that by taking the number of books read, times it by 12, because there are 12 months in a year, and this is the data for 1 month, and then we're dividing it by 5 because there are 5 people, and that would give us the average. So 10 plus 11 plus 8 plus 10 plus 13, that comes out to 52, times by 12, 624, divided by 5, that comes out to 124.8 books per year. So that's that would seem to support it there, wouldn't it? Okay, so 124.8 books, that's more than 100, so I suppose we should write that down. So 124.8 books, which is more than 100. I'm just writing that up here because I don't have space underneath. Right, so that's that one. Give 2 reasons why this sample should not be used to support her hypothesis. Okay, well, firstly, she's asked people in a book club, so these are people predisposed to enjoying books, then I suppose. So only people who really like books are going to be part of a book club, and therefore you would imagine that they're going to read more books than your average person. Okay, so sample is taken from only book club members, which is likely to be biased. Okay, so and the other reason, you can have all sorts of reasons. The sample is not very big. There's only 5 people, so it's a small sample. 5 is a very small sample size. So 5 is not a very good number of people to ask. You'd want to ask more people. You could also have perhaps that it's just based on 1 month. That month might not be typical. Maybe it was like the summer month where everyone's on holiday and might read. People tend to read more books when they're on holiday than when they're not. So that could be also a reason why they read more in that particular month. So there's lots of other reasons you could have as well. As long as you come up with something fairly convincing, I'm sure you'll get the mark. Question 14. The graph has equation y equals x cubed plus a, where a is an integer. The graph passes through the point 329. Draw the graph for the values of x from -3 to 3. Okay. Now, first off, notice that this is not a complete equation. We've got that unknown there. We've got an a. So I think the first thing we need to do is work out what a is. Now, luckily, they've given us a point where it passes through 329. So a line passes through 329. So that means we can sub x equals 3, y is equal to 29 into the equation. And then the only thing left in it then that we don't know will be a. So we can work out a from there. So y is 29. And that is going to be equal to x, which we know is 3 at that point. 3 cubed plus a. So 29, 3 cubed is 927, isn't it? So 29 is equal to 3 cubed, which is 27 plus a, which means that a must be the difference between the two. It must be 2. Okay, so a is 2. So then the equation that we've actually got then is y is equal to x cubed plus 2. Okay, now we need to draw the graph between -3 to 3. So let's just create a table of values. -3, -2, -1, 0, 1, 2, 3. Now you've actually got a nice function button on your calculator that you can use. So if you press menu and you go to table, I believe, then you get this FX symbol pop up. That's when we're going to type in our equation. F of x stands for y in this case, so we're gonna type this bit in there, the x cubed plus 2. So notice there's if you've got a Casio calculator, notice you've got a little x in red. So if you press the alpha key, you can press x. So x cubed plus 2. So f of x equals x cubed plus 2. Then it's going to ask me for g of x. Now we don't need g of x here. You can do 2 equations at the same time with your Casio, but we only need 1. And then the next thing is start and end. So we need to go from -3 up to 3. So we're going to start at -3, and then we're going to go up to 3. And we want every value in between, so we're going to go step up in 1. So we get -3, -2, -1, 0, 1, 2, 3. And then you'll see that you get this table of results that pops up, and then they're the values then that we need to plot. So -3, you can see from the table, is -25. -2 goes with -6. -1 goes with 1. 0 goes with 2. Let's scroll down. 1 goes with 3, 2 goes with 10, and 3 goes with 29. Okay, so that's a super easy way of just generating all the numbers that you need from a table, and then we can plot these straight in. So then we've got coordinate pairs, haven't we? So -3 -25 is the first coordinate, so -3 -25. I'll plot a point there. Then the next one, -2 -6. -2 -6 is going to be there. -1 1, -1 1. 0 2, 0 2. 1 3, 1 3. 2 10, 2 10. And 329, 329. And notice it's got that distinctive cubic curve, so it's kind of going up and then kind of bending and going back up again. It actually should be flat in the middle there. Briefly. So let's just join it up with a nice smooth curve. It's actually a little bit tricky to do on the computer. I'd prefer to do this with a pencil. Okay, there we go. That's not too bad though. It should look something like that. Question 15. When you earn money, you pay income tax. The amount you pay depends on how much you earn that year. You pay 0% for the first £12,500 you earn. Then you pay 20% on the next £37,500 that you earn. Then you pay 40% on the next £112,500 that you earn. So one year, Kim paid £9,260 in income tax. Work out how much he earned that year. Okay. Right. So now, obviously, if you're paying 0% on £12,500, then you're going to pay nothing at all, are you? So 0 times 12,500, that comes out to be 0, obviously. 20% of 37,500, so the most you can pay in that kind of standard rate of tax is going to be 0.2, 20% written as a decimal, times by 37,500. What does that come out to be? 0.2 0.2 times 37,500. That comes out to be £7,500. So you can see that Kim has paid more than that then. So she must have earned more than the 12,500 and 37,500. Okay, so she's got a little bit of money in the next band up that she's paid. Okay, so how much did she pay in the top rate? So if she's paid 9,260 altogether and 7,500 of that was in the middle band, then she must have paid 9,260 minus 7,500 in that that higher rate. 9260 subtract 7,500. So that means she paid £1,760 at that top rate of tax. And if she paid 40%, and that was 1,760, then how much did she actually pay tax on? We need to kind of do an inverse percentage here, don't we? So if 40% of her money is equal to 1,760, then 100% of it, of that band, you're going to have to divide by 40 times by 100 then, aren't you? So divide by 40 times by 100, that's £4,400 that she must have paid 40% on, so she ended up paying 1,760, so she ended up paying 9,260 altogether. Okay, so she earned the full amount here, 12,500, where she paid no tax. She earned the full 37,500 here, where she paid £7,500 of tax, and she must have earned a further £4,400 here at the top rate, so she ended up paying that £1,760 in tax. So how much is that altogether? Adding those up then. So I've already got 4,400 on my display, so let's add on the 37,500 and the 12,500. So that is a grand total of £54,400. 54,400 then. She earned £54,400. She did well. Question 16. A building company employs 2 labourers, 14 joiners, 9 electricians and 8 plumbers. For a job, the company needs 1 of each type of worker. In how many ways can the company choose the 4 workers? Well, the total number of ways, total selections. Well, you can have 2 picks for your labourers, so you've got 2. You're going to have 14 picks for your joiners, so that's 14. You're going to have 9 picks for your electricians, so that's 9. And you're going to have 8 picks for your plumbers, so it's just 8. So you have to multiply all those together then. So 2 times 14 times 9 times 8, that comes out to be 2,016. So there are 2,016 different ways you could pick those 4 workers from that group of workers. It's quite a lot, isn't it? Question 16b. 1 labourer and 2 plumbers are on holiday. In how many ways can the company now choose the 4 workers? Okay, well, if 1 labourer is away, so now we haven't got 2 to pick from, we've only got 1. And then if 2 of the plumbers are away, then we haven't got 8 to pick from, we've only got 6. So now the total selections are going to be 1 labourer, 14 joiners, 9 electricians, 6 plumbers. Okay, so I suppose you don't really have a choice for labourers. There's only 1. That's why multiplying through by 1 doesn't change anything. So 14 times 9 times 6, then that comes out to 756 different ways now. Okay. Question 17, f of x equals 3x squared minus 4x plus 8 for all values of x. Jenny says f of 10 must be equal to 2 lots of f of 5 because 10 is 2 times 5. Is Jenny correct? Show working to support your answer. Well, I know it isn't going to be correct because that would assume that the function was linear. So if you double your input value, you're going to double your output value, which means you have a straight line graph, and you don't have a straight line graph here. It's a quadratic, so it isn't going to be the same. But I suppose I better do some working. All I'm going to do is work out f of 5 and f of 10 and show that f of 5 times 2 is not equal to f of 10. Okay, that's probably the easiest way of doing it rather than writing down what I just said. So let's just write down f of 10. What's f of 10 going to be? So that's 3 lots of 10 squared minus 4 lots of 10 plus 8. What's that equal to? So 10 squared times 3 is 300 minus 40 plus 8. That is 268, isn't it? Okay, so f of 10 is 268. F of 5 is 3 lots of 5 squared minus 4 lots of 5 plus 8. 5 squared is 25 times 3 is 75 minus 20 plus 8. 75 take away 20 is 55 plus 8 is 63. Okay, so then 2 times f of 5 then is going to be 2 lots of 63, which is 126, and that is not equal to f of 10. Therefore, Jenny is not correct. So you do need to remember that to answer the question. So is she correct? No, she's not correct. Make sure you've got an answer to the actual question and don't assume the examiner is going to understand that this supports your answer and that's enough. It isn't. You need to state it. Okay. Question 18. Work out the two roots of 7x plus 1, 2x minus 3 is equal to 0. Circle both roots. Now the exam board highlight words when it's common for students to overlook them. So if you see words that are highlighted, just bolded like that, just double check what you understand what they're telling you. So two roots, we need to find both the roots here and circle both of the circled answers, not just one. Okay, so one root we can get by making the first bracket equal to 0. So 7x plus 1 is equal to 0 will give me one solution, and the second solution I'm going to get if I put the second bracket equal to 0. That's because if I've got two things multiplied together to give me 0, then one of them must have been 0 to start with. Okay, so rearranging for x then, 7x plus 1, taking 1 away from both sides, I'm going to get 7x equals minus 1, dividing both sides by 7, I'm going to get x is minus 1 over 7, and then so it's that one there. And then 2x minus 3, taking the 3 to the other side, I'm going to get 2x equal to 3. And then dividing by 2, I'm going to get x is 3 over 2, which is that one there. Okay, we are done. Question 19. Here is a cuboid. We're told that DH is equal to 8 centimeters. That's already marked on the diagram. DH is here, look. DH is the line between them, and that's 8 centimeters, and DB is 13 dB. Where's that? It's that one there, isn't it? It's equal to 13. Okay, so both of those are given. It's always just worth reading these numbers at the top because sometimes they're not on the diagram, and if you don't notice that, then the questions are pretty impossible to solve. Okay, so just double check it's on there. Work out the size of angle DBH. Where is angle DBH? So starting at D, going from D to B to H, we're actually talking about that angle there then, aren't we? Okay, that's the one we're trying to find. Okay, so I want to find this angle here. Okay, well that should be fairly easy then, isn't it? Because I want that angle, let's call it theta. It's a right angle triangle. I know the opposite, and I know the adjacent. And because I know my trigonometry, and I know TOA, I know that I need the tangent ratio. That's the one that's about opposite and adjacent, isn't it? Okay, so tan theta equals op over adj. Okay, and then we're going to sub in the numbers from our diagram then, aren't I? So we know that the opposite is 8, so that's the numerator, and the adjacent is 13, that's the denominator. Okay, so then we want theta, which is tan to the minus 1 then of that 8/13. Okay, so reaching for the calculator, we can get the inverse tangent by pressing the shift key. Shift, tan, and then I'm just going to use the fraction key to enter that fraction, 8/13. What's that then? That's 31.6. 31.6 degrees. Now part B says, using your answer to part A, work out the size of angle ECG. Okay, so again, let's just work out where ECG is. E to C to G. Well, E to C is not marked, so I'm going to draw that line in first. Okay, so E to C. I'm going to draw in the rest of the triangle as well. So we're going to be using E to G as well, I think, because we need a right angle triangle to use. Okay, and we're going to use that length there. Okay, now this is a right angle triangle. The right angle is up here at G. Okay, and we want to find E to C to G. So ECG, it's that angle there that we're looking for. Okay, let's get rid of the blue. Okay, so that's the angle we're looking for there. Now, do we know anything? Well, we know CG, that's the same as this one here, isn't it? Same as HD. So that's going to be 8. So we can just write that down. So CG equals DH, which is equal to 8 centimeters. Now, what else do we know? Do we know anything else? Well, presumably EG is going to be the same thing as DB, isn't it? Okay, can you see it's another diagonal from one corner to the other along the top face. So EG, this length here, is going to be the same as DB here, which we already know is 13. Okay, so that's equal to 13 centimeters. Okay, so what is that angle down there then? So if that's 13, so here, if this is my angle, let's just mark it theta again. Now at this point we could just use trigonometry again, but you could also notice that we've got congruent triangles here, haven't we? So my triangle EGC, my triangle EGC, that is congruent to, it's the same thing as this other triangle, isn't it? BDH. Okay, so basically this triangle here is the same thing as this triangle here upside down. So because we already know this angle down here, we just calculated it to be 31.6, then presumably that one there is also going to be 31.6. So then we can work out theta just by taking it away from 90, because we've got a right angle triangle here and here, so the other two angles got to add up to 90, so 90 subtract 31.6, that is going to be, it comes out to be 58.4 degrees. Okay. The other thing you do, you could just use, like I say, you could do trigonometry, inverse tangent 13/8, but it did say using your answer, which I tried to do, although I think it'd be quicker just to use tan again. Question 20. We're given the point P, which is at -1, 1, and we're told it's a point on a circle center, origin, radius r. Okay, so here it is here on the circle. It's that point there. Okay, and we want to work out the value of r, which is the radius of this circle. Okay, I'm going to draw in the radius from the origin to my point P. Okay, let's just draw that line in. So basically we're trying to find the length of that line, aren't we? Okay, I'm also going to draw another line. I'm just going to drop a vertical line down from P. Okay, so that meets my axes at a right angle. So this is going to have a height of 1 and a baseline of 1. Okay, so we could use Pythagoras theorem then to work out the length of r. So r squared is going to be 1 squared plus 1 squared, isn't it, using Pythagoras theorem? In other words, r squared is 2, making r equal to the root of 2. Okay, r equals root 2. Question 21. Juice is sold in small bottles and large bottles. The volume of the large bottle is 1,125 milliliters, and we're given a ratio of the volume of the small bottle to the volume of the large bottle as 2:5. A cafe has small glasses and large glasses, and the volume of the small glass to the volume of the large glass is 4:7. A small bottle fills 6 small glasses with no juice left over. How many large glasses can be filled by the large bottle? You must show your working. So we've been given the ratio of these bottles. So for every 2 units in here, milliliters, we're going to have 5 milliliters in here. Okay, so how many milliliters are going to be in this one then? We can find that by taking 1,125 and then dividing it by 5 and timesing it by 2. That will tell me how many are in the smaller bottle then, won't it? So 1,125 divided by 5 times by 2. That means my smaller bottle has a capacity of 450. This is 450 milliliters. Okay, now a cafe has small glasses and large glasses. Volume of small glass, volume of large glass is 4:7. A small bottle fills 6 small glasses with no juice left over. Okay, so how much juice is that then? A small bottle fills 6 small glasses. So if we've got 450 milliliters altogether and we divide that by 6, then we should get the capacity of the smaller glass then, shouldn't we? So the small glass then is going to be the capacity of the smaller bottle divided by 6. What's that then? 450 divided by 6. That comes out to be 75 milliliters. Okay. So we know that the volume of the small glass to the volume of the large glass is in the ratio 4:7. So small glass to large glass is in a ratio of 4:7, and we've just worked out that the small glass is 75 milliliters. So what does that make the larger glass then? So if we can take 7, divide it by 4, times it by 75, we should get the capacity of the large glass. So 7 divided by 4 times by 75. It comes out to be 131.25. So 131.25. So therefore the large glass is 131.25 milliliters. How many large glasses can be filled up by the large bottle? Okay, so then we just need to divide then the volume of the large bottle by the capacity of the large glass then, isn't it? So number of large glasses filled is going to be the size of the large bottle divided by the capacity of the large glass. Okay, what does that come out to be? 1125 divided by answer 60/7, that's 8.57. Just going to write down 8.6 glasses. Now obviously you can't serve 0.6 of a glass in a bar. People tend to complain, so you're going to be able to only fill up 8 glasses and have a little bit left over then, aren't you? So that means 8 glasses. Question 22. The only solution to x squared plus bx plus c is equal to 0 is x equals 5. Work out the values of b and c. Now again, look, they've bolded this. The only solution. Okay, that means it's a repeated root. And so if one solution is x equals 5, then one of the factors is going to be x minus 5. And if it's a repeated root, it's going to be x minus 5, isn't it? Okay, so you're going to have two solutions in the same place, x minus 5, x minus 5. Multiplying out those brackets, that's going to be x squared minus 5x minus 5x plus 25. In other words, I'm going to get x squared minus 10x plus 25. Okay, and then comparing that with what I had to start with, b then is going to be the coefficient of x, it's going to be minus 10, and c is going to be the number on the end, it's going to be 25. Okay, so b is minus 10 and c is 25. Okay, if you're going to look at this as a graph, you're going to have a quadratic, and it's just going to be touching the axes here at 5. Okay, so that's what your graph will look like, which is why we have only one solution. Because normally what happens is you have two, don't you? The graph cuts the axis twice. Question 23. We've given the ratio of x to y is 1/4 to 2/3. What is x as a fraction of y? Circle your answer. Ooh, this is not so nice, is it? Because it's all fractiony. Let's get rid of the fractions first off. So if I got the ratio of x to y and it's 1/4 to 2/3. Now if I multiply everything through by 12, I'll get rid of the fractions on both sides. Okay, so 12 lots of 1/4, that's equal to 3, and 12 lots of 2/3, 12 divided by 3 is 4 times 2 is 8, so it's 3 to 8, isn't it? That's the ratio. So for every 3 x's you have 8 y's. Okay, so what is x as a fraction of y? Okay, so we want to find x in terms of y then. So what is x in terms of y? So x is what y? Well, if you've got 3 x's for every 8 y's, then to find x from y, you have to take y, divide it by 8 and times it by 3, don't you? Okay, so it's going to be x is equal to 3/8 of y. Okay, so it's that one there. Question 24. We need to describe the single transformation that maps shape A onto shape B. Now, just looking at it, you might be forgiven to thinking it's a rotation, because you've got one in the top left corner, one in the bottom right corner, and it's been inverted. But actually B is smaller than A, so we've actually got an enlargement here. Now it's going to be a fractional enlargement because your image is smaller than your object, and also it is going to be a negative enlargement because the image and the object are inverted, okay, turned upside down. So first off, I'm going to say it's an enlargement That's going to earn me the first mark. Now this is a 3-mark question, so I get the first mark for picking the right transformation. Now to describe an enlargement, you need the scale factor and you need the center of enlargement. Okay, so the scale factor we can find by finding 2 matching lengths on object and image and dividing one by the other to find out how many times bigger one is compared to the other. Okay, now if you have a look at triangle B, this line here along the bottom, that actually corresponds to this line up here on A. On A it is 4 units, on B it is 2 units. So then the scale factor then is going to be the length of B divided by the length of A, which is a half. So it's a scale factor of a half. Okay, so it's an enlargement, it's a scale factor of a half. Your image is half as big as the object. And now we just need to find the center of enlargement, which we can give as a coordinate. Okay, but what is that coordinate? Well, the easiest way to do that is to find matching points on object and image and join them together. Okay, so if I've got this point here, it matches up with that one there. So using a ruler, I'm going to draw a line from one through to the other. Okay, and then we're going to do the same for other matching corners. So that there's the corner with a right angle, corner with a right angle. Let's join those up as well. And then finally the other corner. Let's make that one blue. This one matches with this one. Let's join those up too. Although you probably can do it with just 2. But I like to put the third one in just to double check. Now you should find that all these lines cross through the same point, which is this point here, isn't it? And that is the center of enlargement. So that is the point 1 minus 1. 1 minus 1. Okay, and that's my answer. So it's enlargement, scale factor half, center of enlargement 1 minus 1. Question 25. Here is a sketch of a speed time graph for the first part of a journey. We know that the total distance of the journey is 130 kilometers. How far is left to travel? Okay, well, distance traveled is the area under a speed time graph. So if we find out the area of all these different sections, add them all up together, that is the total amount of distance traveled. Okay, so this shape is made up of 3 different areas. We've got this first section here, which is a triangle, and then we've got this second section, which is a rectangle, and then we've got one more section, or you could treat it as 2. You can either say that it's a little triangle and a big rectangle, or you can just calculate it as one trapezium. And what we're going to do is we're going to work out all of those various areas and add them together. Okay, so first up, this triangular part here then, this is going to be well, it's a triangle, so half base height, isn't it? Now we just need to take care of the units here, because speed is given in kilometers per hour, but time is in minutes, which doesn't really match. It needs to be in hours in order to calculate. We need to have matching units, don't we? So kilometers per hour, we need hours down here, and we've got 5 minutes. I'm just going to use fractions. I'm going to say that 5 minutes is 5/60ths of an hour. Okay, and just use that. Okay, and that's what I'm going to use all the way through. So half 5/60ths for my 5 minutes times my height of 102. Okay, what's that then? Half of 5/60ths times 102. 5 times, sorry, 0.5 times 5/60 times 102. That comes out to be 4.25. So because I had kilometers per hours and hours, then that's going to be in kilometers. Okay, so that's area 1. Area 2 then is going to be this rectangular section. That's just base times height because it's a rectangle. So the baseline goes from 5 to 45. So that's 40 along the bottom, isn't it? And remember, I'm converting that into hours. So that's 40/60ths times the height, which is 102. So again, 40 over 60, it's going to be 2/3, isn't it? 2/3 of an hour, times by 102, that gives me 68. So that's 68 kilometers. And then finally, I've got this trapezium part. Now, again, like I say, you could break this into a triangle and a rectangle if you'd rather, but I think I can cope with a trapezium formula. It's half a plus b times h, isn't it? So it's going to be half of a, which is the first height, 102, plus b, let's just write the formula down, so it's half a plus bh, that's what I'm using, isn't it? So 102 plus 96, that's my second height, times the distance between them. It's the distance from 45 to 60, which is 15 minutes, which is 15 over 60 hours, quarter of an hour, isn't it? Okay, so what's that then? So 0.5 times 102 plus 96 times 15/60ths, or a quarter, isn't it? That comes out to 24.75. 24.75 kilometers. Okay, so then total area is going to be those three areas added together. So it's going to be my 4.25 plus the 68 plus the 24.75. What does that come to? Apparently that's 97 kilometers. So that means that this diagram is showing 97 kilometers of the journey. Now we're told that the total distance of the journey is 130 kilometers. So how far is left to travel? So left is 130 minus what we've calculated, the 97. So that's going to be another 33 kilometers to go. Question 26. Here is a triangular sail. Vicky needs to buy waterproofing liquid for the sail. She will put 3 coats of liquid on each side of the sail. A litre of liquid covers 8.5 square meters of sail. How many 1 litre bottles of liquid does Vicky need? Okay, so Vicky needs to buy waterproofing. She puts 3 coats of liquid on each side. Basically, first off, we need to know how much the area is. Now this is a non-right angle triangle. We're given 2 sides and the included angle. So 2 sides and the angle between them, which is handy because that means we can use our formula, our trigonometric formula for area of a triangle, which is area equals half AB sine C, where A and B are your 2 adjacent sides and C is the angle between them. Okay, so that is a half of A, which is 9.7. So say this one, doesn't really matter which way we do them. So 9.7 times B, which is 3.8 times sine of C, which is 73. So 0.5 times 9.7 times 3.8 times the sine of 73. That gives me an area of 17.6 square meters. Okay, and change. I'm just going to write down 17.6. I'm going to leave that full calculate display, so I might use it in my later answer. Right, so that is the total area of the sail. she has to cover this sail on each side, so presumably it has two sides. So we've got 2 there, and we've got 3 coats, giving us a total of 6 sides to paint then. Okay, so we're going to take the total coverage is going to be that area 17.6 times the 6 coats. We need to give 3 on each side. Okay, so again, look, I've just got the same stored calculator value. I'm just going to times it by 6, so that is going to be 165.7. Sorry, misreading it. It's 105.7. Okay, now again, I'm going to leave that full display because we haven't quite finished yet. So that's the total coverage. Now, a litre of liquid covers 8.5 square meters. So, litres required is going to be the total amount to cover divided by that 8.5 then. What's that? So again, just from my answer, I'm going to divide that by 8.5. That gives me 12.4. So we need 12.4 litres. So how many 1 litre bottles of liquids does she need? Well, she can't buy 0.4 of a bottle, so we're going to have to round that up, aren't we? So she's going to have to buy 13 bottles. So it requires 13 bottles. In part B, we're told that another sail is joined to the first sail as shown. So the original one was on the left foot, and they've added this new bit on the right. Okay. So x is an acute angle. Work out the size of angle x down there. Okay. Now, these are non-right angle triangles, and then so when you're doing non-right angle trigonometry, you need 3 things to work out any 4th thing. Okay. Now, in the triangle where we want to find x, we've only got 2 things presently. We know this angle up here, and we know this length here. Now that is not enough to find x. Okay. Now luckily we know 3 things in this triangle though, so we could use these 3 things to find a 4th thing about this triangle. And if we make that thing this line here, the length of that line there, then we'll then know 3 things in the second triangle because they share that edge, don't they? Okay, so I'm going to find that long edge of the first triangle, and then I'm going to use that length that I found plus the 2 other bits of information to find x. Okay, right. So in the first one, let's label up these triangles because it hasn't been labeled. Let's call this A, B, C, D. Okay, so in triangle A, B, C, the first triangle, okay, then what have we got? We've got, so using cosine rule in triangle A, B, C, then b squared equals a squared plus c squared minus 2ac cos b. So subbing in that in then, a is 3.8, so 3.8 squared plus c squared, 9.7 squared, minus 2 times 3.8 times 9.7 times the cosine of 73. Okay, so tapping that carefully into the old calculator, 3.8 squared plus 9.7 squared minus 2 times 3.8 times 9.7 times the cosine of 73. Comes out to be 86.98. Okay. But remember, we want b and not b squared, so b is going to be the root of that then. So root answer, it comes out to be 9.33. Okay, now again, I'm writing down 9.33, but I'm leaving the full calculator display on my calculator, so I'm going to carry on using that in a sec. Okay, so that's the first one. So now let's move over to the second triangle. Now in the second triangle, I have been given two pairs of opposites. I've got angle A and side A down here, which is opposite A. So let's call that little a. And I've got side B, which is opposite, which is also, I suppose, is equal to D, isn't it? Little d, because it's opposite angle D, which is x. That's the angle we're trying to find. Okay, so when you've got two opposite pairs like that, then we're talking about the sine rule. So we're going to be using the sine rule in triangle ACD. Okay, and we want to find the angles, so we're going to write the angle on the top. So the sine rule says sine A over A equals sine C over C equals sine D over D. Okay, and now which bits are we going to be using? We're going to be using D and A, so we're not going to be using C, are we? Haven't got C, don't want to find C, so not interested in that bit there. Okay, so sine A over A equals sine D over D. So subbing in what we know, sine A is sine 42, so sine 42 over little a is 8, and that's equal to sine D, which is our x that we want to find, divided by our D, which was we found to be 9.33. Okay, so rearranging for x then, so x is going to be, well, all we really need to do is take that and move it up here in front of the sine. So it's going to be 9.33 lots of sine 42 divided by 8. Okay, now remember that 9.33, I'm going to use my full calculator value that's still stored in the calculator from earlier. So I'm just going to take my answer and I'm going to times it by the sine of 42, and then I'm going to divide it by 8. And that comes out to be, sorry, that's the sine of x, isn't it? I should have really written sine x there. Sine x. Okay, so that's what I've got here. I've got the sine of x, and that is equal to 0.78. Okay, so we want x, so shift sine answer. That comes out to be 51.3 degrees. Okay, so that's my answer, 51.3. Question 27. Here is a quadrilateral PQRS. We're told that P to S is the vector A, S to R is the vector B, and R to Q is the vector C. They're already marked on the diagram. And then it goes on to say that X is a point on PS where P to X to X to S is 1 to 2. Y is the point on RQ where R to Y, Y to Q is 2 to 1. Is XY parallel to PQ? Show your working to support your answer. Okay, so let's have a look at this second diagram. X is a point on P to S where P to X to R, X to S is 1 to 2. That means that for every 1 you've got here, you've got 2 here. In other words, the distance from P to X is 1/3 of the distance from P to S. So from that I can know that the vector P to X is 1/3 of the distance of P to S, and I know that P to S is a vector A, so then that is 1/3 of A. Okay, so P to X is 1/3 of A. Similarly, I can say that if R to Y, Y to Q is in a ratio of 2 to 1, then R to Y, vector R to Y, is going to be 2/3 of the vector of R to Q. We know that the vector R to Q is C, so that's going to be 2/3 of C. Okay. Now, how does that help us? Well, is X to Y parallel to P to Q? Well, X to Y hasn't been marked, so let's just draw it on. That's X to Y. So what we want to know is that line parallel to that one or not? Okay. Now the way we can do that is we can find the vectors X to Y and compare it to the vector P to Q. Now if they are parallel, then they're either going to be the same vector or one is going to be a scalar multiple of the other. Okay, and that means that they have the same direction, even if they have one is a multiple of the other in terms of its length. So we're going to find X to Y and we're going to find P to Q in terms of the vectors that we know. Okay, now first off, let's do P to Q because that's the easy one. P to Q. Now you might think I can just get some P to Q down here. That's what I'm trying to find, but I don't know anything about that route. Okay, all the vectors I've been given are along the other route, so from here to here, from here to here, from here to here. Okay, so we have to use the routes that we know when we're using vectors. So P to Q is the same thing as P to S plus S to R plus R to Q. Okay, in other words, it is A plus B plus C. That's my vector P to Q. Okay, now my vector X to Y, that is going to be X to S. I'm going to do a similar thing. I'm going to go from X up to S, down to R, down to Y. Okay, so I'm going to say X to S plus S to R plus R to Y. Okay, so X to S is going to be, what did we say it was? X to S. Oh, well, we did the other way around. We did P to X, didn't we? So I found the wrong thing earlier. Well, I found P to X, but actually I wanted X to S, but it's a similar thing. Rather than P to X being 1/3 of P to S, X to S is going to be 2/3 of P to S, isn't it? Okay, so I'm just going to change this one. I'm going to say that vector X to S is 2/3 of P to S, which is 2/3 of vector A. Okay, and then so X to S, that's 2/3 of A plus S to R, which we know is vector B, plus R to Y, which is 2/3 of vector C. Okay, so are they parallel? Well, clearly they're not. Okay, now if I had 2/3 of B as well, if I had 2/3 of A plus 2/3 of B plus 2/3 of C, I could factorize out 2/3 and I have 2/3 of A plus B plus C, but I do not. Okay, I've got the coefficient of B is not the same as coefficient of 2/3 of A and C, and therefore they are not going to be parallel. So I can say that vector X to Y is not some multiple of vector P to Q, and Therefore, they are not parallel. Question 28, f of x equals 2x minus 3 and g of x equals x squared. Show that f to the minus 1 of 55 is equal to f of g of 4. Okay, right. Now, this first bit, f to the minus 1, that means the inverse function. So we need to find the inverse function first. Okay? Now, if I've got f of x equals 2x minus 3, let's just say y is equal to 2x minus 3 to start with and rearrange for x. Okay, so I can make x a subject by adding 3 to both sides. I'm going to get y plus 3 is 2x, and then dividing both sides by 2. I'm going to get x is equal to y plus 3 over 2. So once I've made x a subject, I can then take this here as my kind of form for my inverse function for x. So then f to the minus 1 of x is going to be that same setup but with an x where the y is. So it's x plus 3 over 2. Okay, so that's my inverse function of f. Now I also want to find f of g of x. So what's f of g of x? Now that's taking g of x and putting it inside function f. Okay, so when you kind of do these from the inside outwards. So you start with the function g and then you feed it into the function f. So what I'm going to be doing is I'm going to take this value here and I'm going to sub it into f where I see x. Okay, so f g of x, I'm going to take function f and I'm going to replace the x in it with the function for g of x. So that is going to be equal to 2, not x, I'm going to write g of x there, 2 lots of g of x minus 3. Okay, so removing the brackets, that's just simply 2x squared minus 3. Okay, so now I've got my fg of x and I've got my f minus 1 of x. I can evaluate them for those two expressions. So f to the minus 1 of 55, that's going to be 55 plus 3 over 2. What's that then? 55 plus 3 is 58, divided by 2 is 29. And f of g of 4 is going to be 2 lots of 4 squared minus 3. Just subbing into replacing x with the value 4. So 4 squared is 16. So 2 times 16 minus 3. 2 times 16 is 32. Take away 3. That is 29. Okay, so we've done it, haven't we? So therefore, should really write it down. Therefore, f minus 1, 55 does equal fg of 4. I'd write it at the bottom, but I don't have space.
So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.